Yeah, so today we are going to talk about building media players with React Native, how to approach that problem with React in general, and how to use React Native abilities and features to actually, make that stuff happen. So, first slides from my talk were about me, but Chris already mentioned what I was going to say. That you probably, if you recognize me, you probably recognize me from Twitter, as I'm releasing React Native every 2 weeks. So if you will have any questions about how this process looks like and how we do these things, feel free to ask them later. So what matters, like what's the most important thing about React Native, and what's one of the most important things for me is better developer experience with React Native. And one of the things that are kind of crucial when we are talking about developer experience with React Native is native modules. And that's one of the reasons that I've made with Alexei RNPM, which allowed us to link native modules to our apps. That process was kind of, tricky and kind of complicated for newcomers, so that we decided to make an automated tool that will make it easy. So essentially, we've done all these things to, make the process of working with native modules easy for everyone. And now you may be asking the question why, right? Because React Native is all about JavaScript and React. We keep saying that, we keep saying that React Native is cool because you can target multiple devices by just using JavaScript and React, right? So let's take a look. Here's the list of React Native APIs as it used to be a month ago. I think that changed recently. And there is some stuff to control alerts, action sheets, animations, and other APIs. So it's like more or less 35 modules we can use. And the question is that all mobile app can do for us? Here's, for instance, a list of some of the iOS APIs. Is there any iOS developer here, or someone with iOS background? Do you know maybe like a rough number of all the APIs?
Talking about categories of APIs, like those? Like core video represents one.
Just everything that's
a lot. More than most people can go through in a few years.
Yeah. Yeah, actually I did that and it turned out to be more than 4,000. Like no one knows the numbers. But someone mentioned 4,000 during one of the keynotes, so it's more than that. So it's like 110 times more than what React Native has to offer, out of the box. And now the question is, does it even make sense to ship that stuff with React Native then, so that we can build all these crazy things just with JavaScript? Well, the answer is no. Because what matters to us is the stability. We bet on React Native because we are looking for better solutions to writing cross-platform apps, right? Because essentially the biggest problem when working with iOS and Android applications is that you usually have to duplicate the logic. So that creates two sources of truth that can potentially break, and you have two sources to fix. So that was one of the biggest selling points of React Native, that you can target multiple devices while still keeping your logic, in a single place. And it's becoming even more important because if you think of React Native as an abstraction layer that lays behind your app, it's important that we make sure that it works well and it doesn't break. Because if you're writing your app by your own, using, I don't know, Objective-C or Java, and it breaks, you know where to look for a problem, right? Because you made the app, so if you got an exception saying that there is a problem with scroll view, you're like, okay, I have 5 scroll views in my app, so potentially this is causing an issue. But if you get a random exception from React Native that you probably don't even know what is saying, then you spend a lot of time just trying to figure out, how to approach this problem. So we have to make sure that the core that we ship with React Native is as small as possible, and the APIs that we have, are the smallest subset that allows you to write apps, but still is kind of extensible. And that's the place where native modules come into the business because they wrap native code, they wrap native platform APIs and SDKs so that you can use all the platform features as much as you want. So essentially, if you'll take a look at the implementation of React Native, you'll see that all the modules that you are using on a daily basis, like keyboard, view, text and path, all these modules are based on top of that contract. So it means that everything that we have inside core can be built by you as well. There is no private APIs or hidden features, so if that was possible to do with React Native inside core, then it's probably possible for you to also build something similar. So let's take a look how a simple JS native code looks like. I'm not going to be diving into the specifics of how native modules work in general, like the communication process between native and JS. If you are interested, we can talk about it later. Anyway, on a higher level, if that's one of your first time React Native, you import a JS module from React Native. In this case, we are importing image picker iOS just to demonstrate a simple API, and it has an if it can use camera that returns a boolean. As you can see, it's an async callback that tells us whether camera can be used or not. And problem is that React Native is just like the logic that you write with React Native is just JavaScript that runs inside your VM. And the VM is just like V8 or JS core, so there is nothing that would, there is nothing inside the VM that would tell us whether the camera can be used. There is no window that camera that whatever that can be used. So it becomes tricky to how this is happening actually. There has to be something lying behind this that will tell us this information. And in fact, if we will check out the source code, it turns out there is a native method somewhere inside the code that actually calls into the UA image picker controller API, which is a native API in iOS, and asynchronously calls callback that was passed for JS, passing the boolean which tells us whether camera can be used or not. So it's just a single line of code. And essentially, making the process of writing these things, writing these native modules, leads us to writing better apps, right? Apps that can satisfy any use case that we want. Stuff like barcode scanners, card scanners, Apple Pay, whatever we want, becomes trivial and easy to write, and we don't have to spend ages on making that happen. And so, following on that, a few months ago, when I was just working at the company, I was on a call with a client, and he said, let's build a media player. And I have to say, my first impression was that I wasn't really convinced to use React Native, right? Because, of course, our client wanted to have a cross-platform solution, wanted to roll out the player on both Android and iOS at the same time. But, 6 months ago, things like background music playback on Android were not even possible. So it's like we were kind of trying to be on the bleeding edge and see what was possible or not. So it's been a huge research to us. Because we, eventually we decided to do it in React Native. So it's been exciting times that we spent on that. We discovered quite a few interesting patterns. So today, essentially, during these slides, I'd like to share with you what we have learned and what are the tricks or tips that you can use on a regular basis when writing native modules to write better React Native apps. So before we start, let's take a look at a typical media player. If there are any Apple Music users, you probably look at that and smile because the new interface is kind of ugly. I think this is the old one. So there's tons of features on these, so I decided to break that up into 3 slides. As you can see, the features of the player that we will be about to implement are progress bar with seeking, previews, next, start, stop buttons, and some other stuff like repeat, shuffle, track options. There is also, other features that are hidden, like playing next track, adding to app text, downloading offline, deleting, migrating, adding to playlist, whatever else we can think of. And there is like a lot of things that are not even visible on the screen that we have to, create, like handling incoming calls. You have to pause and play back if there is someone calling you. Interruptions, like another app is playing music. Lock screen, widgets, some car audio headphone stuff, background playback. Of course, so there's like a lot of stuff to work on. And you probably agree with me that it's quite a lot. And at first, when we decided to tackle this problem, we didn't even know where to start. Like, that was kind of like a huge topic to target and to create and wrap. But what we knew was that these APIs, differ on iOS and on Android. They have their own features, bugs, issues, and life cycles. So instead, of kind of thinking about the problem in general, we decided to focus on the core of the app, which was the playback. And now, if you think about the playback itself, it's really just a side effect, right? Playback is a side effect to state changes that are triggered by the user interface or other input devices. And so, just like when you trigger, dispatch, Redux action, and you expect an HTTP request to be fired and then some other actions to be taken afterwards, the same thing could be, that could be compared to the playback. The HTTP action could be just, a call to native module saying, okay, play this or play this music from this resource. So without an action being dispatched, the HTTP request would never fire, right? So, and so instead of focusing on the side effect, instead of focusing on the speakers, we should focus on the real core, real source of all these things, which is the play queue, and how we are going to perform mutations on it, right? Because play queue will be that thing that will be changing and will be over time telling our underlying side effect what to do as a result. Now, if you remember from the previous slides, I was using verbs like shuffle, remove, and add. So, like, what data structure these kind of suggest to you? Maybe push? Yeah, right. I mean, I was assuming that JS developers are, A+ from the data structures, so yeah, it's an array. So the play queue is nothing more than just an array of songs that are queued for playback, and we can assume that the side effect, that the player service producing side effects, is always guaranteed to react to these changes. And if we make this assumption at the very beginning of creating the player, the entire development will automatically become trivial. Because, if you don't think about how the music is played at this point, if you only focus on that array, things like how to push, so how to add song to the queue, how to remove it, how to shuffle, it all become easy because it's just about mutating the array. So the mutations that you can perform on the array are just simple, operations that are, not that even complicated, like concatenating the array, changing boolean. These are kind of simple. And now, the great thing about this approach is that if you keep this kind of information inside JavaScript, you can ensure cross-platform stability very easily because the logic is living in a single place, and up to this point there is nothing specific to any of the devices or any of the platforms. So the logic of your player is easily portable between iOS, Android, Windows Phone, or whatever else you want to do in the future. And another thing that probably no one realizes until the app is shipped is that you can write tests very easily. Because if you have ever tried to write tests for React Native, it's not that easy. You have to set up sometimes an entire app if you want to test, the elements, click buttons. Like you can use IPU, for instance, but it's not that easy as testing web applications. The good thing about this approach is that the logic is pure JS. Like there is not even a single reference to React Native, so you can test out all the actions, like action creators in Redux, the reducers or these mutations very easily without even putting up the entire environment. And still, be pretty sure that what you have created works. So we already know that the play queue is somehow the state of our app, and the player service is what's going to produce the side effects. However, before we actually go ahead and implement the player service itself, we have to think how we will connect these things to React. To React tree ideally, so that the mutations and state changes are reflected by the UI. And if the song is not playing, then the buttons are different than when the song is not playing. And so we decided to do it purely using state, just because the idea of components tree and these set state things and life cycles was very, very ideal to this use case, because we only had to connect the state of the player with a single subset of React tree, so that when the song was changing, we had a cascading update for the entire tree of components reflecting music states, so it wasn't actually polluting the rest of the app. Plus, the entire app didn't have Redux, so it was kind of obvious that we don't want to introduce it just for the sake of this. However, it's kind of okay to use Redux, I think, for this. But you have to remember about a lot of pitfalls here, because, for example, you have stuff like if you have a seek bar with a place inside the current track, you ideally would like to keep the position somehow in state or in Redux store, because that's how we write our apps, right? And the problem is, if you are going to dispatch Redux action every second, and there are going to be some animations, like someone will transition, there is going to be a few bottlenecks. So the state thing was kind of what allowed us to do some tricks to make it fast. However, I'm thinking that with Redux it could be also possible. And so, first thing we have to do is, we have to somehow build the play to the app itself, so that these changes on the array are actually causing some updates and life cycles to be called. And so, if you are using state, this is a very, very kind of standard approach of using state inside the app, that you put state inside a context and you create a higher order component, which is more or less like Redux Connect, and just wrap the outermost component of your app. In this case, we have the app component. This is usually what you pass to app registry. So, yes, the implementation of it is kind of straightforward. For now, it's just a wrapper. So it just passes props, it's been given, and renders a player component. So now that we have an abstraction that we can start with, we can add the state to that wrapper. And the state is actually the thing that we already described. That's our play queue and all these properties. In fact, I have to tell you, in a real app, I have like 20 other properties, because I had to trim down the example to make it fit the screen. However, if you will go ahead and implement other things like interruptions, handling incoming calls, you will be holding some state flags to make that happen. But you will see that it's kind of easily customizable. So, yeah. So now the last thing to do with the wrapper is to actually add these methods that are going to perform these mutations. This is just a simple call to saying state. So yeah, it's like we just built Redux in like 2 minutes for the sake of this. So the beauty of this approach is that the UI that we have inside the app becomes, just reflects what we have in state. And so it's very important to remember this, because if you are essentially about to write a media player app, and you will take a look at Spotify or Apple Music, you will see that these UIs are kind of complicated. So without using React, like if I was about to go fully native with this approach, I would be probably wondering how to make the data manageable in a way that I can maintain it and it's not getting out of control. And with this approach, it's kind of easy because everything is in a single place, and these mutations are kind of small. So yeah, that's why I prefer this over writing native implementation in terms of logic. And so the component that we haven't mentioned yet, like we mentioned that it's there, it's the player, but we don't know what it's going to do yet. it's the one that will be producing side effects. And if this is a React component, naturally we'll be passing it some props. And so if this is the player, like what are like the two most important things that player always has to know?
What it's playing.
Yeah. So what is playing? So that's track. And
if it's playing.
Right. Yeah. So these are the props that you have to pass to the component to start with, so that you can actually see whether it works or not. So the initial implementation could be just a regular component that renders null and has some props described. This is, by the way, a flow type declaration. And now the question is how we can make this player do something, because it's just a React component. And now, since the play queue is living inside state and everything is passed through props, there are some lifecycle methods that will be called during the app lifecycle so that we can put in some logic inside. And these are the component did mount and will mount. So we can use component did mount to tell the service that whether the song should start and whether the next song should start and whether the current song whether the next song should be played, track should be switched, or whether the current song should be stopped or not. And as you can see, that method, despite being inside the player component that is producing side effects, is still easily testable because it doesn't have any calls to native interface. So we can still just kind of mock these functions like onTrack did change and onPlay did change, and just make assertions based on whether they are called or not under certain circumstances. So it's still very, very easy up to this point to ensure that your app is going to perform well. And so onTrack did change, as we already seen, gets called every time the track changes. So now we can put some logic inside this method. For example, if track changed and there is no new track, then it means we have to stop. Simple case when, for example, an array is empty and the next track is undefined, that would be when we return. If the player is playing and the next track is defined, just kind of start playing next song. Otherwise, this else case is not mandatory. This is kind of my application specific code. In this case, I just wanted to update the native UI so that, because if you have post state inside Spotify and you switch song, you still get next song preview and lock screen in a post state. So I had to call the set track kind of thing, which is just like start, but it doesn't change the song. And so onPlay change is even more easy to task to write because it's just resume and post based on the prop is playing. So up to this point, we already knew that betting on React Native was a right choice, because without writing any piece of native code, we were able to kind of write a vast majority of what we had to write. The entire UI was now able to start working. We could have just write the entire app as of now. The only problem was that the music was not playing, but the entire interface was kind of working, so the experience was like muting the speakers and just kind of having fun with the app. And all that was thanks to React philosophy that promotes these declarative approaches, single state tree and passing down all the things. So yeah, that was kind of one of the best decisions that we had in terms of writing this application. And so at this point we could have just stopped, hired some iOS Android engineers, and just told them, okay guys, these are like 5 methods that you have to implement. These are like start, stop, resume, set track, and play. So 5 methods. However, I was always talking about native modules and native code, and in fact, I'm kind of, I used to be iOS developer, so I was kind of obvious that I'm going to take this task without outsourcing elsewhere. So yeah, so now it's going to be the native part. Huh? What?
You gotta wrap it up already, Rusty.
Oh really?
Yeah.
How many minutes do we have?
You're about into your Q&A right now.
Okay. Any native? I mean, I'll do it quickly. So So yeah, we have the player manager inside the component, and now if you create native module inside React Native, there is the native modules namespace, and you always import the stuff from the player from that namespace. And this is how you can create a native module inside Objective-C. It's just a simple class. You use some macros from React Native like RCT export module, and that makes the module to be automatically exported to JS. It provides that method under the native modules namespace. Then you use export method to export methods so that they are available on the object. And the cool thing about this is that these objects are created dynamically when you start the app. So React gets the information based on these macros and just creates a player manager object, and then loops through all the macros that you define and just creates these methods on that object so that you can call them. And so one of the methods that I wanted to show is the play method, just because we wanted to focus on app, not on writing player logic, and we were not that good in writing player stuff. We used third-party library that has methods like play, etc. So essentially, writing it was just a matter of copy-paste from the examples. And there are quite a few other interesting things about that I can tell you later. However, the audio player itself is just a single line play data source and passing data source. So at this point, after that single line, the music was playing and everything was kind of done. Then I just focused on explaining other things like how to switch to the next track, how to do other crazy things. I can show you some code examples later if you want. And that's the final diagram that I created myself, so I hope you like it. It just explains the approach that I was describing through the entire talk. That there is the state container that contains the state. This is our play queue. You call set state, and the producer that's producing side effects calls into the native layer, native manager that performs some changes, and then through the event layer back to producer. These are the callbacks that are working in React Native. And the cycle is kind of used to be cycle, but to be honest, I couldn't make it, so made it that way. Anyway, that cycle repeats, and essentially, native modules help us write better apps, and apps that can be used like 80% of the logic. So yeah, next time you will be about to write something like this, something that seems to be kind of complicated and seems to have a lot of native code. Try out React Native, because I hope that I somehow showed you that it's kind of possible. And there used to be time for questions, but I think we don't have it, so thank you.
We can maybe take one or two. I'm sorry we had to rush in. We started the meetup a little bit late tonight.
We didn't make the gap, whatever, not the break, enough space for,
For applause. Oh yeah, sorry. Round of applause. We're going to have time for one or two short questions. Anybody have any? Back here? Okay.
In the meantime, I'll add that I was aiming to open source this code like a month ago. I'm still kind of late, but you can ping me on Twitter along other people. I'm on that.
The question was, I've done a little bit of React Native to native Objective-C Java code. Has anyone found a way to do synchronous calls into native code?
Actually, you can. There is undocumented API that's mainly created because Facebook needs that for some advanced gestures implementations. It's not recommended, and it has some, kind of bottlenecks. But yeah, it's possible. I can show you later a link to discussion on Facebook that people were linking to that method. On Android, it's definitely possible. I think on iOS as well.
I'll chat afterwards.
Anybody else? One more? All right, now is the time I was going to ask for the applause.
I mean, the more the better.
Well then. Yeah.